Hello, my name is Xavier Rodriguez, and this is my physics podcast from Mr. George Stewart's Section 2 class. Today I'll be discussing buoyancy and density. As you know, density has two equations, which are mass density and weight density. Mass density is density equals mass divided by volume, and weight density is weight divided by volume. And I got kind of curious to see what will actually sink or float. So I decided to drive all the way back to Tampa, Florida, to use my parents' pool. And this is what we got.
Alright, so we're going to test the buoyancy of these objects. First, we got a basketball full of air.
Yeah.
Will it float or will it sink?
Yeah.
Oh, that's my best friend behind the camera right now. We got this polyester shirt. Will polyester sink or float? Piece of stick. Most realistically, going to break in half. See if it changes anything at all. Obviously, a piece of styrofoam. A random sandal. Not going to miss this. And why not? For the whole freaking hamper in there. Focus on this. Well, water's kind of cold.
And the basketball floats.
Will you look at that? And we'll get it later.
The rubber floats.
Styrofoam. Gee, I wonder what happened with him. You never know.
And it floats.
Alright, polyester shirt.
I got a feeling that one's going to sink.
I think it'll float. Just in case it does sink. Don't want to go in there. Yeah, man,
Just give it a second, though. It's going to soak up.
Ah, you got a point.
Wait. Ah.
Sinks. The more water adds into it, makes it sink.
It makes it heavier due to the weight.
Yeah. This shirt's buoyancy actually changes. Obviously, the stick is a heavier object. Will it float?
Doesn't necessarily mean it's not going to float.
Let's see.
And it floats.
Now, you see changing the weight at all, or change the size of it, will affect anything with its buoyancy. No? I don't want no more dirt in the pool that we already have. Alright, hamper.
Throw it in. Don't do that. Throw it inside because it's got holes.
Ah, good point. See, the holes affect anything in here.
Ah.
The holes definitely do affect it. Ah, crap. We'll edit that out.
Okay. Use the stick.
Oh god, that didn't work. Oh god. Now for a special surprise test. A pink tricey. Very heavy object.
But it floats.
Yeah. This proves to show that buoyancy has nothing to do with weight. Very much. No matter how heavy something object is.
And those are our results. We used a basketball, a sandal, a hamper, a polyester shirt, a pink tricey, which belongs to my niece, by the way. It's not mine. I don't ride around the world using a pink tricey. And a stick. We broke the stick in half to see if breaking it in half will actually change the density of the object, which it didn't. It stayed the same and still resulting in floating. I believe I messed up right there saying that weight doesn't have to do anything with buoyancy of object. I kind of forgot about the weight density equation, which is density equals weight divided by volume. But all in all, I hope you enjoy watching my experiment and my podcast. I want to say a special thank you to my parents for letting me use their pool. Even though I don't live here no more, still gotta love me. I want to say a special thank you to my friend Michael, who helped me out recording this. And a special thank you to Mr. George Stewart for teaching me some of this other stuff. And have a great day.